Greetings everyone. Welcome to my YouTube channel for Kangaroo Maths and Science Academy. Together we strive for a change through education. Ladies and gentlemen, I believe you had a wonderful examination for Fiscal Science Paper 1. And even though it was not a fair paper for you guys, I mean for some of you, but most of the learners are saying the paper was just fair. But remember, it's not the end of the time. You still have other opportunities. You still have a chance to get good marks in Fiscal Science Paper 2. All right. Without wasting time, guys, I want to take you through the tips on how to ace Fiscal Science Paper 2, which I will be writing particularly on Monday. All right. Now, if this is your first time watching my video, kindly go through my YouTube channel ID at Kangaroo Maths and Science Academy, and you'll find other videos that can assist you in getting good grades in Fiscal Science. Kindly don't forget to like, subscribe, and hit the bell button for future video notification. Right, without further ado, ladies and gentlemen, let's start with the tips on how to pass Fiscal Science Paper 2 with good marks. Right, now, if you can easily check that under Fiscal Science Paper 2, there are actually the topics that are covered in chemistry. It's what you call the organic chemistry. It's actually what you call the organic chemistry, followed by number 2, the rate of reaction, and number 3, it's chemical equilibrium. Then number 4, it's what you call acid and bases. Then the last one, it is electrochemical reaction or electrochemistry. So you need to be able to know all these 5 topics. But now I will start with the first one, which is called organic chemistry. Ladies and gentlemen, organic chemistry comes in 3 topics, subtopics. The first one, we have nomenclature. The second one, we have physical properties, physical and chemical properties of organic compounds. Then the last one are the organic reactions. And usually in the exam, ladies and gentlemen, organic chemistry comes in 3 questions. You find that the first question is based on nomenclature, the second question is based on physical property, and the last one is based on the organic reaction. So you need to make sure that you spend more time on organic reaction, and it's one of the easiest. Right. However, on the nomenclature, ladies and gentlemen, I've already created a video. There is a video that I've created for nomenclature, and there is a link that is shared below. Kindly follow the link and watch this video in order to understand the nomenclature. Because this time around, I'll just summarize it a bit, but actually you must watch the video so that you can be able to understand. So just there is a link that I've shared below. Kindly go through it in order to understand nomenclature. Right, without wasting time, ladies and gentlemen, let's start with the organic chemistry. In the video that I've shared below, you'll realize that if you watch it, you're going to find that I've already defined what is a homologous series, what is a hydrocarbon, what is a functional group, because these are the terms that one must be able to know. So homologous series, hydrocarbon, functional group, structural isomer. And in the video, we have 3 types of isomers, of structural isomers. Number 1, we have a chain isomer. The second one, it's a positional isomer. And the third one, it is the functional isomers. So you need to make sure that you go through this. And again, you need to know the 9 homologous series in terms of their functional group and their general formula. And you must also differentiate between hydrocarbons that are saturated and hydrocarbons that are actually unsaturated. And you need to also know the 3 kinds of structural isomer, as I said, chain isomer, positional isomer, and functional isomers, and also give their examples. And be able to name organic compound by using the IUPAC system, which is International Union of Pure Applied Chemistry. Then also you need to be able to know the types of alcohol, such as the primary alcohol, secondary alcohol, and tertiary alcohol. Then again, one must be able to define what is an empirical formula. What is an empirical formula? So you need to be able to define the term empirical formula, which is the whole number ratio of atoms in a in a compound. I apologize. So it is the whole number ratio of atoms of in a compound. Then again, ladies and gentlemen, you need to be able to do calculations that are involving the empirical formula when you are given the percentage composition, and also be able to calculate the molecular formula when you are given the molar mass and the empirical formula of a compound. Already I've created a video for the nomenclature on organic chemistry, so kindly follow the link that I shared in order to understand this. But now, for us to start with physical and chemical property of organic compound, we need to remind ourselves about the 9 homologous series, in the 9 homologous series, using what you call the let me write this. So it is the R with triple A's, R, double A's, the K must have the C inside. So it's R, K. These are the 9 homologous series. Now, the first one being the alkanes, you need to know this. The first one being the alkanes, the second one being the alkenes, and the other one is the alkynes. Then haloalkanes, Then we have the alcohols, followed by the aldehydes in this order. Then we have the ketones, carboxylic acids, and the last one we have esters. So these are the 9 homologous series that you need to know in order to understand the physical properties of organic compound, ladies and gentlemen. Right, which means that when you are dealing with organic chemistry, remember I said it comes in 3 equations: the nomenclature, the physical properties of organic compound, and also the organic reactions. But in order to enjoy this, you need to know these 9 homologous series. But under the nomenclature, you need to know these homologous series and their functional group. If you watch the video, you'll see that the functional group of an alkanes, it's CnH2n plus 2, alkenes, CnH2n, alkynes, CnH2n minus 2, alloalkanes, CnH2n plus 1 with an X, and the X is for the halogens. Then the alcohols, it's CnH2 2n plus 1 with the OH, or if you don't want we don't write it as CNH 2n plus 1 OH, it's still the same as CNH 2n plus 2 with an O. So this is the general formula of an alcohol, but the general formula of an aldehyde and a ketone are the same. It's CNH 2n with an O, but of a carboxylic acid and an ester are also the same, which is CN, it's CnH2nO2. So you need to be able to know this. So kindly watch my first video so that it will be easier for you to understand nomenclature. I strongly believe, ladies and gentlemen, you are okay. Right, let's now move on to the physical properties of organic compound. Right, under physical properties of organic compound, a learner must be able to define the term boiling point, the term melting point, and also the term vapor pressure. You need to be able to define what is a boiling point, what is a melting point, and what is a vapor pressure. And also, you need to be able to know the types of intermolecular forces. Okay, you need to be able to know the types of intermolecular forces that are actually acting between atoms in a compound. So now, number one, we know that a boiling point is the temperature at which the atmospheric pressure is equal to the vapor pressure. The atmospheric pressure is equal to the vapor pressure, which means we know that 1 atmospheric pressure is equals to 1.3 kilopascal. So we are saying the temperature at which the atmospheric pressure equal to the vapor pressure. This is called the boiling point. So it's very important for you to know what do you mean by a boiling point. Then again, you need to be able to define what is a melting point. A melting point is the temperature at which the solids and the liquid phase of a substance are at equilibrium. Very important. Then again, you need to also be able to define what is a vapor pressure, which is the pressure exerted by a vapor at equilibrium with its liquid in a closed system. You need to be able to define this, ladies and gents. Now, without wasting time, guys, for you being able to define what is a boiling point, what is a melting point, and what is a vapor pressure, it's very important again to know the types of forces that can act between atoms. And these types of intermolecular forces, I apologize, the type of the intermolecular forces. This is very important, ladies and gentlemen. In your syllabus, there are 3 types of intermolecular forces that you need to know. The first one is called what we call the hydrogen bonding. The hydrogen bonds or the hydrogen bonding. The second one is what you call a dipole as the type of the intermolecular forces. And the last one is called what you call a London or the dispersion force. These are very important. A learner should be able to know these 3 types of intermolecular forces that can act between the atoms in a compound. So to know the IMF or the intermolecular forces, you need to be able to relate this type of intermolecular forces with either the boiling point, the melting point, or the vapor pressure. This is one of the easiest, it's one of the easiest question under organic chemistry, right? Again, ladies and gentlemen, one must be able to know the factors that can affect the boiling point, the melting point, and the vapor pressure. And these factors include the following: the chain length, the branching, and also the types of the functional group. And you need to be able to explain this. How will they affect the boiling point, the melting point, and the vapor pressure in terms of the type of the intermolecular force and also the energy that is needed to overcome. So it's very, 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 very important to know the types of forces that are actually intermolecular forces that are acting between atoms. All right. Now, since now you are able to define what is a boiling point, what is a melting point, and what is a vapor pressure, I want to talk about something very important. Let's now relate these three things that I just mentioned there: the boiling point, the melting point, and the vapor pressure. Before we move on, ladies and gents, let me now talk about the relationship between the boiling point, the melting point, and the vapor pressure in organic chemistry. Number one, let me say this. Let me write something very important here. Number one, I want us to talk about the boiling point. Let me compare the boiling points versus melting point. Ladies and gentlemen, boiling points and melting points are directly proportional. I strongly believe you know what we mean by directly proportional. What does this mean? It means the higher the boiling point, result to higher melt. So it means these are directly proportional. A substance that has a higher boiling point can also have higher melting point. So it's very important for you to be able to understand this. So it means the relationship between the boiling points and the melting points. It means a substance that can have a higher boiling point, it can still have the higher melting point. But now, when we relate the boiling points or either melting point with vapor pressure, the melting point or the boiling point, when related to the vapor pressure, they are inversely proportional. What does this mean? It means a substance or a compound that has a higher boiling point, a compound that has a higher boiling point will have a low vapor pressure, will have a very low vapor pressure. But a substance that has low boiling point will have a higher vapor pressure. That's why in most of the cases, substances that are highly flammable, which means substances that have the ability of catching fire easily. So it means they can catch fire easily. Most of them, they have a very low boiling point. Their boiling point is very low. That's why the vapor pressure is high. So it means substances that have that are highly flammable, they have a higher vapor pressure. That's why if we compare liquids and gas, between a liquid and a gas, which one has a higher boiling point? Obvious, the answer is liquid. Most liquid has higher boiling point. But when you compare with a gas, most gases are highly flammable, which means most of them have higher vapor pressure. Hence, their boiling point is very low. So it's very important to relate these, ladies and gentlemen, when you are dealing with the physical properties of organic compound. Because sometimes in the exam, they will tell you that two substances have different vapor pressure. Maybe one substance has a vapor pressure of 125. I'm just giving an example, kilopascal, and the other one is 130 kilopascal. Then they ask you, between compound A and compound B, which one is highly flammable? Obviously, it will be compound B. And between the two, which one has a higher boiling point? Obviously, it will be A. Because a substance that has a higher boiling point, the vapor pressure should be smaller or lower. So it's very important, ladies and gentlemen, to be able to know the relationship between boiling points, melting points, and vapor pressure. Right, let's now proceed. So now I want us to talk about the factors that can affect the intermolecular, the factors that can affect the boiling points, the melting points, and also the vapor pressure in relation to their intermolecular forces. Number one, ladies and gentlemen, we have what you call the chain length. We'll talk about this. The chain length. Secondly, we have the branching. Thirdly, it is the functional groups. So it's very important for a learner to be able to know the factors that can affect boiling point, melting point, and vapor pressure. But now, before I talk about these guys, before I talk about the chain length, the branching, and the functional group, let's now go back to the homologous series that I just indicated earlier, because we need to use them here, and the intermolecular force. Let me write it here. Remember I said K, which is the alkanes, alkynes, alkynes. Then the second one is haloalkanes, alcohols, aldehyde, ketones, carboxylic acids, and then esters. Guys, listen to me very well. Within these 9 homologous series, these 9 homologous series do not have the same type of intermolecular force. Some have the same, some don't have the same. So I'll do this. I will say from the alkanes up until the alkynes, I'll group them together. Then from here, from the remaining ones which I did not group, I want to take this. For now, I want us to take the alcohols and the carboxylic acid. So I'm going to write them this side. So I've taken the alcohols and the carboxylic acid. I want to write them here. Ladies and gentlemen, within these organic compounds that I've grouped, like this one and the remaining ones, they have different kinds of intermolecular force. So from today, you must know that when you are dealing with alkanes, alkenes, and alkynes, the alkenes, and alkynes, these have a type of intermolecular force called the London forces, which is the type of the van der Waals forces, or what you call a dispersion forces. And this is one of the weakest type of the intermolecular force. Then again, the carboxylic acid and the alcohol. These are the only two types of organic compounds which have what you call the hydrogen bonding as the type of intermolecular force. So the hydrogen bonding as the type of intermolecular force, it's only found in alcohols and also in carboxylic acid. But the alkanes, the alkenes, and the alkynes, which are hydrocarbons, they have what you call the London forces or the dispersion force at the type of the intermolecular force. Which means these other type of intermolecular, if homologous series have what you call the dipole forces. So it means the dipole force as the type of intermolecular forces. It's found in haloalkanes, it's found in aldehydes, it's found in ketones, and it's also found in esters. So in the examination, ladies and gentlemen, when you are given an organic compound, you need to be able to know the homologous series to that organic compound belongs to. You must be able to know the type of functional group. The type of the intermolecular force that organic compound has. So if it's about alkanes, alkenes and alkynes, they have what you call the London force or the dispersion force, which are the weakest. These are the weakest type of intermolecular force. Then, but the hydrogen bond compared to the London and dipole, these are one of the strongest, or the stronger type of intermolecular force. But I will talk about this, ladies and gentlemen, which means this is just in between. So in the examination, when you are given homologous series, you must be able to know the type of intermolecular forces that is found between that. Remember, I used K, which means here the alcohol and the carboxylic acid are the ones that have hydrogen bonding. Then the alkanes, the alkenes, and the alkynes, these have London, which means the remaining ones has dipole forces as the type of intermolecular force. So it's very important when we are dealing with physical and chemical properties of organic compound. So very important, ladies and gentlemen, you need to be able to understand this. Let's now continue. All right. Just a minute, ladies and gentlemen. I want us to go and talk about, let me create another space where we can talk about this again. So I'll just try to share a document here so that everyone can be able to see it. Okay, right. Right. As I was saying, let me write those. Okay. I apologize, guys. Okay, I apologize, guys. Just a minute. Okay, right. So as I was saying, let me write those okay. So I'll just do it like this. Say okay. So remember this, we said it's alkanes, alkenes, alkynes. This. Okay, just a minute. Alkynes. You can just write the haloalkanes, alcohols, aldehydes, ketones, carboxylic acid. Then the last one is an ester. Now, remember I said the first three has what you call the London force as the type of London or dispersion. But now, within this, it's only alcohol and carboxylic acid, which has, I'll write them here. So if we take the carboxylic acid and other one is the alcohols, these two has what you call the hydrogen bonding as the type of intermolecular forces. And the remaining ones, the one I did not mention from here, which means haloalkanes, aldehyde, ketone, and esters, these as what you call the dipole forces. As the type of intermolecular force. And within this, I said the London are the weakest type of the intermolecular force. But the hydrogen bonding, these are one of the strongest, let me just say, strongest type of IMF as compared to the London and dipole. But now I want you guys to understand something very important, especially on the issue of alcohols and carboxylic acid. I want to add something very important. The carboxylic acid and alcohol both have hydrogen bonding as the type of intermolecular force. But however, on a carboxylic acid, the hydrogen bonding as the type of intermolecular force on carboxylic acid, most are stronger than that of an alcohol, even though they have the same type of intermolecular force. And what could be the reason why we say carboxylic acid have stronger intermolecular force or stronger hydrogen bonding as compared to that of an alcohol? Right. Here is the reason. In the, what is this? Carboxylic acid. Carboxylic acid has two sides. Has two sides of hydrogen bonding or hydrogen bonds as compared to that of an alcohol. Whereas an alcohol has one side of hydrogen bonding. So you see that this is the reason why a carboxylic acid tends to be stronger than that of an alcohol. And these are exam typical equations, ladies and gentlemen. So it's very important for you to understand this. Now, let's take this further. Let's take this further. Now, I want you guys to relate to this with something. I want to write it down here so that you can be able to understand. Right. I want to do something like this. Then don't forget, guys, because we'll be using it time and again. So I'll just write, okay, let me just write BP for boiling point, MP for melting point, VP for vapor pressure. BP boiling point, MP melting point, and VP vapor pressure. I think I said something. The higher the boiling point, the higher the melting point, the lower the vapor pressure. I believe you're following. You understand how I got this? Remember, I said the relationship between boiling point and melting point are directly proportional. But between boiling point, melting point, and vapor pressure, when you compare the two, they will be inversely proportional to vapor pressure. So which means the higher the boiling point, the higher the melting point, but the lower the vapor pressure. But in the other way around, the lower, if we were to, the lower the boiling point, the lower the melting point, but the higher the vapor pressure. And this has to do with the type of the intermolecular force. Guys, let me do this. I just want you to understand something here. If you understand this, it will be easier for you to get the point. On this side on the left, let me call this on the left, and let me call this on the right. If we use a compound, this is just a way for you to remember. Let me just write stronger here. Let me just write the weaker. So what does this mean? Listen, but I just want you to understand something here. If we have a stronger intermolecular force, or if you have a compound that has a stronger intermolecular force, then that compound will always result to higher boiling point, higher melting point, and low vapor pressure. But if we have a compound that has a weaker as the type of the intermolecular, if it's weak, then the boiling point will be low, the melting point will be low, and the vapor pressure will be high. That's why most of the alkanes or most of the alkenes or most of the alkynes are used as fuels or gas, like petrol and diesel and so forth. Why? It's because they have the weakest intermolecular force, and because of that, their boiling point is very low, their melting point is very low, but their vapor pressure is higher. That's why if we were to compare carboxylic acid and an alcohol, the boiling point of carboxylic acid as compared to an alcohol will always be higher than that of the alcohol. Unless if we are not comparing, but it will be higher than that, because why? The carboxylic acid has two sides of hydrogen bond as compared to that of alcohol. And because of that, as the number of sides of hydrogen bonds becomes more, then it means the intermolecular force will be strong, which means more energy will be needed to overcome. Actually, because that time we can say more energy is needed to break the bond, but the general way is just to say more energy is needed to overcome. Okay, just okay, so as I was saying, which means that it's very important for a learner to be able to understand this. But now the question is, what are other factors that can affect the boiling point, the melting point, or the vapor pressure? Number one, let me mention them. Number one, it is the chain length. Let me talk about this. Organic compound that has longer chain length require, or actually they require more energy for the intermolecular forces to actually to overcome. And because of that, it means the boiling point will be higher because the intermolecular, like energies, more energy is required to overcome this stronger intermolecular force. And in that case, it means as a result, the boiling point will be higher, the melting point will be higher, but the vapor pressure will be low. So what I'm going to say, the longer the chain length of the compound it is, the longer the chain length, more energy is needed to overcome the intermolecular force. Actually, let me say, the longer the chain length, it means stronger IMF, it's actually needed. So it means it needs more force. But this more force actually means more energy. It's actually required to overcome this intermolecular force. And as a result, since there is more energy that is needed to overcome the intermolecular force, it means we'll have a higher boiling point, if you're talking about boiling point, and also melting point, but lower vapor pressure. It depends on what the question is talking about. So it means a compound that has longer chain length tends to require, or they need more energy for them to overcome the intermolecular force. I believe you guys are following. So this is one of the factors that can affect the boiling point, the melting point, or the vapor pressure. Number two, another type of another factor that can affect either boiling point, melting point, or vapor pressure is the issue of branching. But branching has to do, we can relate this with the chain length, because a compound that is longer chain length, it means it's actually less branched. Now, let me say this. A compound that is more branched, or a compound that is having more branching, require less energy to overcome the IMF. So it means branching actually reduce the boiling point, the melting point, but it increased the vapor pressure, because now More branching means less energy is actually required to overcome. And since there is less energy that is required to overcome the intermolecular force, then it means the boiling point will be less. Less boiling point or less melting point, but higher vapor pressure. So it's very important for you to understand this. Then the other one is the issue of the functional group. But the issue of functional group goes into this part where maybe we are comparing alkanes and carboxylic. You see, carboxylic acid as compared to this other type of homologous series. This is one of the compound or homologous series that have the strongest intermolecular force as compared to others, which means the boiling point of carboxylic acid tends to be higher than the other organic homologous series. So this is one of the things that you need to be able to understand when you are dealing with physical properties of organic compound, ladies and gentlemen. So once you understand what I just explained now, then you're not going to have a problem in answering physical properties of organic compound. So you need to make sure that you familiarize yourself with that. Then now we move on to the issue of, okay, I apologize. We move on to the issue of organic reactions, ladies and gentlemen. Under organic reactions, you need to be able to know the types of reactions that can take place in two compounds. Number one, we have a reaction called addition reaction, elimination reaction, substitution reaction. Then another one, and this is very important, is called the esterification reaction and the combustion reaction. Then the last one is cracking, which is the type of elimination reaction. Right. Before I talk about the addition, the elimination, and the substitution, let me talk about these three types of the last three types of reaction. Right. Let me start with combustion reaction. In other book, they call it an oxidation reaction. Let me talk about combustion reaction. Combustion reaction, it's usually a reaction that takes place naturally so, where we take the fossil fuels or the fuel, we combine them with oxygen. That's called oxidation because it's the addition of oxygen. Then always it gives us carbon dioxide and water. So which means that when you are dealing with combustion reaction, in your syllabus, we use the alkanes. So if we take the alkanes, we combine them with oxygen, then we're always gonna give us carbon dioxide plus the water when the heat of reaction is less than 0. We'll talk about that later. So if they say to you in your syllabus, they say determine the combustion or write down the combustion reaction of maybe alkanes or maybe butane or pentane or heptane. It's straightforward. You just take your alkanes, combine with oxygen, then you then form carbon dioxide and water. Because in your syllabus, we always talk about the alkanes, not alkenes or alkynes. So let me do one example of a combustion reaction. When you are dealing with a combustion reaction, ladies and gentlemen, you need to be able to know how to balance atoms. If they say write down the combustion reaction of any alkane, you just take that alkane, combine it with oxygen, then gives you carbon dioxide and water. Then you balance, you just balance. So as an example, let's say we have the following. First of all, kindly, if possible, watch the first video so that will be easier for you to understand this. We have a general formula for an alkane. Alkane has a general formula of CnH2n plus 2. For example, if we say we speak of butane, butane belongs to alkanes and it has 4 carbons. So which means where there is N here, if we can put 4 here where there is N, it means the molecular formula of butane will be C4. 4 times 2, it's 8 plus 2, this becomes 10. Plus the oxygen, then we add this with carbon dioxide and water. Then now, if they say write a combustion reaction, we need to balance this. And to do that, it means we're going to simplify. We look at the number of atoms. Okay, carbon has 4 atoms of 4 atoms, whereas this side it's only 1. So what can we do to balance this? It means you have to put 4 here to make the atoms to be balanced. Secondly, the atoms of carbons are balanced. Now we look at the atoms of hydrogen. Hydrogen here has 10 atoms. Whereas this side hydrogen has 2. And to balance this, it means we need to put 5 here. Why? Because 5 times 2, it's now 10. Which means that the atoms of carbon and the atoms of hydrogen are balanced. Now we can look at that one of the oxygen. And to do that, it means now we know this side oxygen has 2 atoms, but this side, when we work this out, we'll say, okay, fine. 4 multiplied by 2, it means oxygen, it's 8 atoms this side. Plus 5 multiplied by 1, 5 multiplied by 1, it's 5, which means 8 plus 5, this gives us 13. Now, we need to balance this. It means we must have 13 atoms of oxygen on the right and 13 atoms of oxygen on the right. And to do that, we'll say, okay, well, already we have 2 atoms of oxygen on the left-hand side. So the question is, what can we put here such that when we multiply by 2, it will give us 13? Remember, 13 is an odd number. So it means we have to put 13 over 2. Why? Because 13 divided by 2 multiplied by 2, it will give us 13. But now, to avoid these fractions, what can we do? We need to avoid this 13 over 2. It means we have to multiply the whole equation by 13. Mom said by 2, I apologize, guys. And it means the final answer will be 2. Okay, let me just write it. Will be 2, what? It will be 2C4, 2C4H10 plus. When you multiply by 2, then it gives us 13. And from here we'll have the O2 oxygen. Then here we multiply by 2, it will give us 8 atoms. 8, then the compound will still be carbon dioxide plus. We multiply by 2, then this becomes 10 with H2O. Now let's now confirm. So you see that here the 8 and the 8, so the equation is balanced. The equation is balanced. So you can try other compounds. You can try other compound. They have to balance, ladies and gentlemen. I believe you are following. Ladies and gents. Okay, then now, so To do this, then we're going to sort of find, we understand combustion reaction. We can try other examples, but I'll create another video for that. Now, again, let's move on to the issue of esterification. Esterification is the type of reaction whereby we react a carboxylic acid and an alcohol to form an ester. So if we take any alcohol, we react it with a carboxylic acid under a catalyst called sulfuric acid. I strongly believe you know what is a catalyst. Then these two, through the removal of water, then they will form what you call an ester plus water. Means the water will be an inorganic substance or compound. So this is called an esterification. And ladies and gents, if you can watch the first video of nomenclature, I have explained the part of an ester, how the ester comes from. Actually, when we are naming, let me just show you a general way of remembering this. The name of an alcohol change and become an il. Then the name of a carboxylic acid change and become an weight. Then this will help you to know the name of the ester. For example, if we take methanol, we combine with butanoic acid under a catalyst called sulfuric acid. Then the name of the ester that will be, this will become methyl. Then this one will be butanoate plus the water. I believe you guys are following. I believe you are following. So it's very, very, very important to understand this. Right, we can now move on. So you need to be able to know what is esterification. You need to know combustion reaction. I've addressed that. Let's now talk about what you call cracking. We need to understand what you mean by cracking. Cracking is a type of elimination. But let me now talk about what you mean by cracking. Okay, a cracking, let me just talk about what you mean by cracking. Cracking is the process of breaking large hydrocarbons into more useful substance or compounds. So cracking is the process whereby we are breaking a very large hydrocarbons into a more useful compound. For example, under cracking, you need to know the following. Usually under cracking, in terms of your syllabus, they take a very large alkane. Then they break it through what you call either thermal or catalytic. But when they break, these alkanes still forms the alkanes plus the alkenes. So it means under cracking, you take a very large alkanes, then you break them, then they will form a more useful alkanes and alkenes. So in the cracking all the time, you must check, it must be alkanes and alkenes. But now, if we break this by using higher temperature and pressure, so it means we're actually heating this. We use a higher temperature and pressure, but with no catalyst. Then this type of a cracking is called a thermal cracking. But if we use a very low temperature and pressure, but in the presence of a catalyst, and this is called a catalytic cracking. I apologize. Catalytic cracking. Okay, just a minute, guys. Okay, so it means, for example, let's say we know in terms of your syllabus, you need to learn up until eight carbons. But we still have compounds that have 9 carbon, which if it's an alkane, it will fall under the no-name. 10 carbon will be the decane. You learn this when you go to university. So if we have this, we know the general formula of alkane is CN H2N plus 2. So let's say with the decane means we have to put 10 where there is N. So it means this will be C10H. 2 times 10 is 20, plus 2 is 22. This is a very large alkane. It's an alkane with 10 carbons. But if we break this, it is in my choice. For example, we can try to break it to have, let's say we want it to have, let's say 6 carbon with, for example, let's say with 12 hydrogen. Then obvious, even if they put X here, you're still gonna get the answer. To say, okay, fine. They already used 6 carbon atoms. It means this should be we must have 4. And to have 4, the hydrogen, which means there's to be 10. Why? Because 12 plus 10 is 22. 6 plus 4, it's what? It's 10. But now we know the general formula of an alkane is this one. But how about of an alkene? It's CnH2n. So it means if you put 6 here, this has to be 12. So you see that this is an alkene, this one. And this one has to be an alkane. Obviously, this is a butane. Guys, are you following? So it depends. It depends with the reaction that we want to get. But now, if we put this symbol for heat, then it shows this is a thermal cracking. Okay, so if maybe we put the symbol, but with no catalyst, maybe they show that there's a higher temperature that is being used here, higher temperature and pressure. Obviously, if there is a higher temperature and pressure with no catalyst, then it's called a thermal cracking. So it's very important to be able to know these types of reactions. So now I've already addressed these 3. Now we can move on to the first, second, and third. Right. Ladies and gentlemen, let me take you back to the issue of nomenclature. Under nomenclature, we have what you call the saturated hydrocarbons and unsaturated hydrocarbons. We know that a hydrocarbon is an organic compound that contains carbon and hydrogen atoms only. So which means a compound that does not contain hydrogen and carbon atom only is not regarded as a hydrocarbon. That's why hydrocarbons in your syllabus, it's only alkanes, alkenes, and alkynes. These are the three hydrocarbons. So it means they contain hydrogen and carbon atoms only. But compounds like haloalkanes, alcohol, these are not hydrocarbons. But now it's very important. We know that alkanes are actually saturated because they contain single bonds between carbon atoms, or they contain no multiple bonds between carbon atoms. So kindly watch the first video. Now, I want you guys to understand, in this syllabus, when we say a substance is saturated, I'm not talking about, I'm still talking about saturated compound. A compound that is saturated, not saturated hydrocarbon. A compound that is saturated means it's a compound that contains single bonds between the carbon atoms. So now, in terms of the structure, we know that alkene, we see it by a triple bond between the carbon atom, which means this is unsaturated. Alkyne is triple bond, alkene is double bond, and alkane is single bonds. So this one is saturated. Now, when we have compound like this, that's why I said we need to first understand the first video. It will be easier for you to understand this. Now, when we say a reaction, it's addition. An addition reaction is the reaction in which the substance is being added onto the unsaturated compound. Right. What do you mean by unsaturated? Okay, fine. When we move from unsaturated to a saturated, right? In terms of your syllabus, ladies and gentlemen, when you talk about a compound that is unsaturated, is the alkenes. So it means alkenes, it's one will be like, yes, alkenes and alkynes are unsaturated, but in terms of reaction, we speak of the alkenes. So when we say a compound, it's unsaturated, it means it contains multiple bonds between carbon atoms. But in terms of reactions, when we talk about unsaturated, we actually focus on alkenes. Now, it means if we say, let's say we have a compound where it had either that it has a double angle, but some, not say double angle, double bonds, I apologize. But suddenly, at the end of the reaction, the double bond is no longer there. It's single bonds. They're just single bonds. It means we moved from unsaturated to saturated. Then that type of a reaction is called the addition rule. So we use USA. So if you, under USA, if you move from unsaturated to saturated, you must know that the type of reaction you are dealing with, it's the addition rule. I'm saying addition reaction. So it's very, 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 very important to understand this. So all the time in your syllabus, when you talk about reactions, when they mention of alkenes, you must know this is an example of an unsaturated. So if we move from unsaturated, then at the end we have a saturated compound. You must know this is an addition reaction because we're using USA, meaning moving from unsaturated to saturated, that is called addition rule. So, but if you want to remember this, I'll just say USA SU triple S, USA SU triple S, USA for unsaturated to saturated is addition. Saturated to unsaturated, it's elimination. Saturated to saturated, it's substitution. Let me talk about this. Okay, so as I was saying that when you move from unsaturated to saturated, then this will become an addition rule. But when you move from saturated to unsaturated, then this will be elimination. I apologize for this addition rule, no, addition reaction. And then again, when you move from saturated to saturated, then you're gonna have substitution reaction. Right, then now let me take this practical. I want us to explain this one by one. Let me stop sharing and send and use another platform to explain this. Now, number one, okay, I'll just do this. USA. Like with USA, we have USA, triple S. Now, let's start with the USA. According to this, it says when we have an unsaturated compound, not unsaturated hydrocarbon, but unsaturated compound, then at the end we get a saturated compound. Then you must know that the type of reaction here is called addition reaction. So if we have a reaction where it is having an unsaturated compound, what do you mean by unsaturated? Those that contain, say, double bond or triple bond between the carbon atoms. But in your syllabus, we only consider the ones that are containing double bond. So what does this mean? It means if we have an alkane, I'm saying alkene, because alkene has double bond, then now suddenly the reaction changes. Then we have the saturated compound. It means the one with single bonds. If the compound now contains single bond, then it's regarded as the saturated. Now, it means in your syllabus, when they give you any, if you're talking about any saturated compound, when you say it's compound, it's saturated. I'm not talking about saturated hydrocarbon, I'm talking about saturated compound. It means can either be alkanes, because they contain single bonds, or they can be alcohols, contain single bond, or haloalkanes. So if we have either the alkanes or the alcohol or the haloalkanes, these are also called the saturated compound. Not saturated hydrocarbon, but saturated compound, because they contain single bonds between the carbon atoms. Now, look at this. In your syllabus, once they give you an alkene, you must know you're dealing with an unsaturated compound. But suddenly you find that you have this. You have an alkene, but at the end, you end up having this. There are four reactions, or there are four types of addition reaction, which we are going to talk about now. If you have an alkene, and suddenly the alkene changes, is now becoming an alkane, or it's becoming a haloalkane, or it's also becoming a haloalkane again, or it's an alcohol. Ladies and gentlemen, if you have a reaction where you had the double bond, the reaction had the double bond in between, but suddenly at the product, there is no double bond, it's just single bonds. Maybe it's an alkane or haloalkanes or the alcohol. you must know that you moved from unsaturated to saturated. So it's USA, which means the type of reaction that is taking place here, it's a addition reaction. But now, addition reaction, why are we calling it addition reaction? It means it is a reaction where we take an unsaturated compound, we add something here, then to result to this. So it means in addition reaction, we break the bond between the carbon atoms. But addition reaction, there are 4 types of addition reaction. I want you guys to listen to me very well. All the time, if we have an alkene, and this alkene suddenly becomes an alkane, you must know that we move from unsaturated to saturated. And this is called addition reaction. But when we have an alkene, then suddenly we remain with alkanes. It means that on this alkene, there was a hydrogen added, hydrogen atom added to the alkene. And this reaction of addition reaction is called hydrogenation, which means hydrogenation occurs only when there is an addition of hydrogen onto the unsaturated compound. So this is called hydrogenation. But when we move from unsaturated, then now we have a haloalkane. Haloalkane can come in 2 ways. It's either it becomes a haloalkane when we have added hydrogen with halogen, and X. Remember, X represents the halogen, which is called the alkyl halides, the halides. In another book, they call it an alkyl halides. So which means that we can still have a halogen when we have added hydrogen with halogen onto the unsaturated compound. Then the product will now, the type of addition reaction will be a hydrohalogenation. Hydrohalogenation. Means we have added hydrogen with a halogen, then it will form a haloalkane. But again, a haloalkane can still be formed when we added halogens only. 2 atoms of halogens. Then this will now be called halogenation. It means it's the addition of halogens onto the unsaturated compound. Remember, I'm saying an unsaturated compound, it's when you're dealing with an alkene in terms of the syllabus. But now, when you have an alkene and suddenly the alkene becomes an alcohol, then you see we move from unsaturated to saturated, then it means it's still an addition. But what could be the possible reason of having an alcohol? It means we have added water. So if you take water molecule, you add it onto the alkene or unsaturated, then it will give us an alcohol. And this is called the hydration. Addition of water. So under addition reaction, we have 4 types of reaction. It's either we have hydrogenation, but the hydrogenation always occurs when we move from alkenes to alkanes only. But when we move from alkenes to haloalkanes or from alkenes to haloalkanes, for this, it's either it is a hydrohalo or halogenation, where we have added 2 atoms of halogens. But when we move from an alkene to an alcohol, then it means this is called hydration, addition of water. So it's very important in the examination to be able to know that when you are dealing with addition reaction, there are 4 types of addition reaction. It's either you have hydrogenation, or you have hydrohalo, or you have halogenation, or you have hydration. But hydrohalo or halogenation only comes when you are forming a haloalkane. The hydrogenation only applies when you move from the unsaturated to the saturated, particularly the alkanes. That's where you have hydrogenation. In terms of the reaction condition, we'll talk about that later. But now I want you guys to understand this, because these are exam typical questions. So in other words, when we talk about saturated compound in your mind, saturated compound, I'm not talking about saturated hydrocarbon, but I'm talking about saturated compound. It means you're referring to alkanes, haloalkanes, and alcohols. I believe you're following. Now, let's now talk about the elimination. Now, the elimination is actually the reverse process of addition, because now we are saying use SU. Remember I said USA, SU, triple S. So it means the SU, it says we are now moving from saturated now to unsaturated, then it will be an elimination reaction. So that's why when you know addition reaction, it will be easier to understand elimination reaction, because it's the reverse process of addition reaction. So it means whatever we have added now, we need to remove it. For example, if we have an alkane is saturated. Now suddenly we have an alkene, which is so we move from saturated to one, so it means it's a SU. And what kind of a reaction is this? It's called the elimination reaction. So it means when we are moving from alkanes to alkenes, it means this is elimination. It means whatever we have added, remember we have added hydrogen, now we need to remove it. Then now it's going to be dehydrogenation, because we are removing that hydrogen. But if we remove the alkyl halides from the saturated compound, then it will form then it will become elimination, but it will be dehydrohalo. It will be dehydrohalo, which means removal, dehydration, dehalogenation, dehydration. I apologize. Dehydrogenation, dehydrohalo, dehalogenation, and dehydration, which means removal. So if you know addition reaction, elimination is just straightforward. Whatever we added, we now remove. So it means in the examination, you need to be able to understand, are you moving from unsaturated to saturated, or you are moving from saturated to unsaturated? If you are moving from unsaturated to saturated, then you know you're dealing with addition reaction. But the question is, what type of addition reaction is that? If you're just moving from alkenes to alkanes, you know, okay, this is hydrogenation. But if you're moving from alkenes to haloalkanes, it means it might be hydrogenation or it might be hydrohalogenation or halogenation. So by looking at the reaction, it will tell you. But if you're moving from alkenes to alcohol, you know it means this is hydration. So it's very important in the examination to know this. But in the context of, before I talk about in the context of substitution, which is called triple S, let me talk about this. in the process of substitution, we have this. Let me explain it first. Remember, USA, SU triple S. So we spoke about the USA. The USA, we spoke about that. The SU, remember I said this is the reverse process of this. Now let's talk about triple S. Triple S means we are having saturated. And at the end, our product still becomes saturated. What does this mean? It means we have a single bond, and at the end, we still remain with single bond compound. So this is an example of the substitution reaction. But usually a substitution reaction can occur in different ways. For example, we can have what we call the type of substitution, which is called hydrohalogenation. The hydrohalogenation can take place on the alkanes, or in some instances can also take place in the alcohols, where we're just adding the two, and these two actually is not, but they swap. X comes that, then another atoms comes into this one. So this is actually called the substitution reaction, but for hydrohalogenation. Let me just do one example. Let's say we have ethane. Remember, eth means two, so it's going to have something like this. Then within this, we just put, let's say we put like, let's say we use hydrogen with bromine. This is just an example. But at the end, you end up having something like this. Plus, what has happened here? It means now we must first check, okay, this reaction, it's saturated because it contains single bonds. I'm not talking about, yeah, it's saturated, but it's hydrocarbon, but usually it contains single bond, fine. So it contains single bond, but at the end, we still have a product that still contains single bond. So you see that we move from what? From saturated to saturated. What has happened? It means that between the hydrogen bromine atom swapped with hydrogen. So it means the position of hydrogen, it's now a bromine. Then the position of a bromine, it's now a hydrogen. You see that this is a type of substitution reaction. And this is one of the example of hydrohalo, because we used hydrohalogenation. And we say hydrogen, we use the alkyl halides. Another way would be, let's say we have an alcohol. It's not about this only. An alcohol, maybe we still use the same HBr. Then what's going to happen if it's sufficient? Then the Br will swap with the OH. Then just like this, so you're going to have something like this. Plus the HOH. You see what happened? This is just H2O. So you see that from here, we had the alkanes. Now the final product, this is a haloalkane. Now here we had an alcohol, but the final product is still single bond, but it's a haloalkane. So you see that this is an example of substitution. But it's not about this only. We can even use water hydrolysis. We can even, but this will be a hydrolysis if you are using water. If we are making a substitution but using water, then this will be hydrolysis. So if you just use H2O, obviously H2O, it's H with OH. But this hydrolysis will not take place when you're using water. I'm saying alcohol. So it means it might take place when you're using, let's say, yes. So it means the hydrogen will now come this side. Then the OH will go. You see, you're now becoming an alcohol. So this is an example of the substitution reaction. So it means substitution reaction, like in the two, both reactions are saturated, but they're just a swapping off. I'm saying the reactants actually swap the atoms. So it means now the product will still be saturated. So it's very, very, very important to understand this. But now let me talk about the case where we're talking about hydrogenation under addition reaction, and also in the context of Markov-Nikov's rule. And there's a Zeff's rule, but the Zeff's rule applies to the elimination. So these are the things that you need to be able to understand, but I'll explain that way by using like examples. Okay, let's say we have the following. Let's say as an example, let's just come with any alkene. So if I take any alkene, let's say I take the ethene. Then within the ethene, then I will have to add hydrogen. So obviously, you see that when I'm adding hydrogen, it means this will break the double bond. And one atom should be placed at the one end of the carbon. So we're going to have something like this. So you can easily see that we move from what? Alkene, which is unsaturated. Now it is becoming asaturated. So you see we're using US, but it means the reaction is what? The reaction is addition. But if I swap this and I use Br, the bromine means to be HX. So if they break, then it means it's going to have something like this. So you see, I've now alkene, but now it's becoming a haloalkane. But if you use two bromine, okay, if it's this will be this reaction. If I use HBr, this will be hydro halogenation. But if I just use the bromine, it will break. Then one of them will be attached at the end of each carbon atoms. Then you see this will become now a haloalkane. But still, this is halogenation. So elimination means is the opposite of this. So you need to check that when you are answering questions, ladies and gentlemen. Now, before this, I wanted us to talk about the case of Markov-Nikov's rule, which applies to addition reaction, particularly when you are dealing with haloalkanes. Actually, let me just say it applies when you are dealing with the hydrohalogenation. Okay, let me just do one example. I want us to talk about the Markov-Nikov's rule. Markov-Nikov's rule. Markov-Nikov's rule, it says, when you are adding atoms, actually, let me just say the alkyl halides, because this one actually applies to alkyl halides, which means the HX. addition of atoms, actually of alkyl halides onto the unsaturated compound. Then always you need to attach, or you need to place the hydrogen atom onto the carbon, with the highest number of hydrogen atoms. So it means, what does it mean? But this one applies only when we're dealing with hydrohalogenation. Let me give you an example. Let's say we have propene. It's an example. And what is this function? This propene belongs to an alkene, so it's CnH2n. So propene, let's say one propene actually. Okay, propene, so it's going to be 1, 2, 3. Let's say the double bond is here. So we have something like this. So hydrogen, 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 hydrogen. Remember how many carbons are here? 1, 2, 3. So if you put 3 here, the hydrogen should be 6. So 1, 2, 3, 4, 5, 6, 5. Let's say we add, because the Markovnikov does not apply when we're adding. If you're just adding hydrogen, there's no need for Markovnikov. If you're just adding halogen, there's no need for Markovnikov. If you're just adding, yeah, it applies to alkyl halides or water. Also in the context of water, yes, water. Now, so it means here, Markovnikov applies, we use it when we're using addition reaction. So Markovnikov says when we are adding atoms such as the hydrogen, the alkyl halides or the water onto the unsaturated, the one with double or triple, you need to place the hydrogen atom, the hydrogen atom onto a carbon with the highest number of hydrogen atoms. So what does it mean? Actually, when we want to get a measure product, this is very important. So which means now, from our reaction here, if we only, as I said, if we add hydrogen then atom, then the Markovnikov is not needed. Markovnikov is needed when we're dealing with, let's say we're dealing with the alkyl halides or water, when we're adding water. That's why you can use Markovnikov. But look what is saying. It says, yes, we have an unsaturated, this is an unsaturated compound. So obvious, when you add this, it means you expect this to break the bond. So what does the rule say? It says, yes, because you are using the hydrogen and the halogen, that's why we call it the alkyl halides. And even here there is a halogen and hydroxide. Then you need to be careful. When you are breaking this bond, you need to attach this hydrogen atom in order to have a major product. You need to attach this hydrogen atom onto a car. We need to attach between the two, by the way. But we need to attach the hydrogen atom onto the carbon that is the highest number of carbons. And what does this mean? It means now we are going to look at the carbons where the double bond is located. It's here. Now, let's do this. Let's say on the first carbon, how many hydrogen atoms are there? It's 2 of them. And on the second carbon, how many hydrogen atoms are there? It's only 1. But now, this Markov says you need to attach or place the hydrogen atom onto a carbon with the highest number of hydrogen atoms in order to get a measure product. So it means here, when we break the bond, ladies and gentlemen, the hydrogen should be placed here. Why? Because this carbon is the one with the highest number of hydrogen as compared to this one. So it means this time around, the bromine should come, the X should come this side. Because if we just put the X on the first carbon hydrogen there, it's no longer a major product, it will be a minor product. So it means for a major product, particularly when you are dealing with the haloalkanes, particularly haloalkanes and the alcohols product, particularly when we have added the hydrogen with halogen. So it means the final result for this would be, if we were to consider, the final result would be this. So it means now you're going to have hydrogen, hydrogen, hydrogen. Here we'll have bromine, hydrogen, 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 hydrogen. This is when we used Markov-Nikov. You see, this now becomes a major product. And this is an example of a secondary haloalkanes. If you watch the first video, you'll be able to understand what we mean by this. But if we want a minor product, means we do not use Markov-Nikov. It means we can place the hydrogen even here. Then bromine comes here. Same applies with when we're dealing with water. It means this take priority. We first place the hydrogen onto a carbon that is the highest number, obviously the first one. So it means the end result will be this. So we still have an alcohol, but this is also a secondary alcohol. So Markov-Nikov's rule applies to addition reaction, but not on all. Because now, imagine when we're just adding hydrogen. There's no need for Markov because we can place them at any. Imagine when we have halogens. So when we break, there's no need for Markov-Nikov because Markov-Nikov speaks of the hydrogen atoms. And this is very, 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 very important. Listen, if you want to get good marks, you need to make sure that you understand whatever I'm explaining. Then under Zaitsev's rule. Zaitsev's rule applies to elimination, which means it's the opposite of Markov. Then with this one, it says, now you need to remove the atoms. You need to remove the atoms from the carbon that has the least number of hydrogen atoms. You remove the carbons, the hydrogen atom from the atom that has the least number of hydrogen atom. But when you look at this, yes, we need to remove bromine here. If we are doing elimination, bromine has to be removed. It's a showcase. But when you look here, how many carbons are here? It's just 3. This side, they're just 3. So we can just remove either this side or that side. Same applies. But there's some instance where you find that you have something like this. So this is according to Zaitsev. It says you only remove the hydrogen atoms from the carbon that is the least number of hydrogen atoms. Let me just do one example. Let's say we have the following. Let's say we have the following, but this applies to, let's say we have the following. Here we have hydrogen. There it's OH, just water. That's hydrogen, 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 hydrogen. Now we need to perform the itself. Let's say we want to remove water from here, H2O. Obviously, when we remove water, how are we going to do this? We're going to have to fine. Yes, we have to remove the OH. It's elimination. We need to remove it with hydrogen. But the question is, do we have to remove with this one, or this one, or that? Now, Zaitsev says, whenever you are dealing with elimination, you need to remove the hydrogen atoms or atoms onto a carbon that is the least, the smallest actually, the least number of hydrogen atoms. Okay, let's do. We need either we remove here or there or there. But now, if you look at the first carbon, how many hydrogen are there? 3. Second carbon, how many are 2? This one are 3. Which one is the least? Is this. So it means we need to remove hydrogen carbon here. So it means when we remove, we're going to take one, these 2, we'll take it out. So it means the final product will be, means we're going to have a double bond here. I believe you have followed. This is according to the Zaitsev's rule. But I'll do an example. I'll do an example regarding this, ladies and gentlemen. So it's very, 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 very important to understand this. Then in terms of the reaction condition, I'll create a video where I'm just talking about the reaction condition only. But for now, I want you to understand this. So it's very, very, very important, ladies and gentlemen. So let's go back. Remember already I've addressed physical and chemical properties of organic compound. Organic reaction went through combustion reaction. We went through esterification reaction. We went through the cracking, substitution, USA, SU triple S, USA, SU triple X, S. So these are the types of reaction. And also we went through the physical property, boiling point, melting point, and vapor pressure. Then now, in the next part, or okay, let me just do this because okay, fine. So it means now we'll also come and do chemical change, endothermic, exothermic reactions, the heat of reactions, which is the energy absorbed or released in a chemical reaction, and also the activation energy and the activated complex. We need to be able to know, we must know this, which is an activation energy is the minimum amount of energy that is needed for the reaction to start. Activated complex is just an unstable transitions from the reactants to the product. We talk about this, draw the potential energy graphs for endo and exo, define what is a positive catalyst. Then again, guys, under rate of reaction, I will advise you to also watch my video. There is a video that I've already created for the rate of reaction. I will share a link below. Kindly watch it too, because this one, I think I'm not going to spend more time on it. Then we'll have to also focus on the chemical equilibrium together with the acid and base. I think I'll spend more time on acid and base. Then the last one will be the issue of electrochemical reaction or electrochemistry. So it's very, very important for you to know this. But now, ladies and gentlemen, I think let me stop here for now. And I want you to just go through what I've just said and try to memorize it on your own. Then I believe your life will change, will not be the same as far as organic chemistry is concerned. But the first thing that I would advise, kindly follow the first video for nomenclature, guys, because if you understand nomenclature, it will be easier for you to understand the physical and the chemical property of organic compound. Right, without any waste of time, see you in the next part 2 video. Thank you very much. Bye-bye.